In this video, we are going to discuss about the DC regulated power supply. So, on the completion of this topic, the students will be able to test the various blocks of the regulated DC power supply. And here we know there is two types of current. One is alternating current and another one is direct current. So in the case of the alternating current, there is nothing but it is an electrical current wave that is whose magnitude as well as the direction will be very cyclically as that of the sine wave. In the case of the continuous current means the direction remains constant but its flow of current is in a straight line. You can see the flow of current in the straight line, that is DC current, and also the AC current, which is an electrical current, is magnitude in the direction which is varying in the cyclic manner, which is shown in the sine. And you can find out the difference of AC and DC. So when current which is flowing when current direct current is flowing, because it is running in a straight line, then it loses its energy when it's flowing in wires. So when this AC current flowing in the sine wave, then it do also lose its energy, because at one time its current state is 0 and one time it can be 1. So if its lose energy is have to be recovered, then it should be easily recovered easily. How to compare this AC and DC means, this AC voltage is usually expressed as root mean square value, so that we can written as Vrms. For the sinusoidal voltage, that is Vrms is equal to Vp divided by root 2. So in this term, Vrms is very useful in calculating this power that is consumed by the load. So if the DC voltage of the VDS which delivers a certain power P in a given load, then an AC voltage of this Vp will deliver the same average power into the same load. So if Vrms is equal to VDC, because of this fact we can say that as RMS is the normal means of measuring this AC voltage. And you can see this transformer, the rectifier. From this transformer you will be getting the AC signal. This rectification purpose will be converting this AC signal into DC signal. So if you are applying some 12 volt AC current means, this rectification factor will changes or converts it into the direct current, the same 12 volt DC current. And next we will be using a smoothing filter. So smoothing filter will remove all the distortion noises which is present in the rectification, and then we will be which is sent to the regulation. So before regulation, some ripples which are present in this current will be removed, that is 12 volt DC with the ripples are removed before it is go for the regulator. After that it will be regulated at the output as a 5 volt DC regulated output. So you can see the structure of this one. From the transformer it is given to the rectification. So in this rectification we have 4 diodes. So in that diodes, from that it is given to the smoothing. So smoothing we use a capacitors 470 μF. So next it is given to the regulation. Before regulation, the ripple factors which are present in this direct current will be removed, and finally the output will be displayed in the 5 volt DC regulated. Purpose is mainly for the to increase or step up or step down the AC voltage which is present in the circuit, and the properties which is laminated to reduce the power losses which is produced through the eddy currents. So here you can see that is from the transformer, if you are getting some input signal or input voltage which you are getting contains a ripple factors, and from it will not be a proper current. So if it is flowing to the rectification will convert the same into DC supply. So with that it converts the DC current, but it contains some ripples, that is some distortions will be there. So the smoothing filter will act as a that is noise removal or pre-processing technique, so that it will remove all those filters, that is it will remove ripple factors which are present in the rectifiers. Then it is given to the output voltage, so that we will be getting a proper stabilized output with no distortions or no output. That is if the input is given as in sine wave means, the proper sine wave will be getting at the output also. The whatever we given at the input, say, that is if the input is given in a proper form, then the same thing will be getting in the output form. There will not be any distortion. So mainly this transformer's operation is mainly based on the principle of alternating current in the primary coil, that is inducing alternating electromagnetic field, which we call as EMF on the secondary coil due to their mutual inductance.